Hey guys, last section of Unit 1. So excited. We are doing inequalities. So I just want to make sure the new part for college algebra is that we're going to be writing our answers in interval notation. We're used to inequality notation. We're used to graphing our inequalities. This is another notation that we use that takes the variable out of it. Okay? So for example, when x is greater than 2, I think you're fine with the open circle and shading everything bigger than 2. Okay, that's what that's what x is greater than 2 looks like on a graph. In interval notation, the open circle is substituted by a parenthesis, and we write 2, comma, infinity. That means all the answers can be found starting the smallest is 2, but not including 2, up to infinity. No x, no y, no z. It's like whatever the variable is, we don't care. It's just start at 2, but not including 2. You start at 2.00000000001. Okay, really close to 2, but not including 2, and you can go up to infinity. Okay, so basically what we're saying is the answers are greater than 2. This, of course, is x is less than 2, open circle. We're used to that. We shade everything to the left. This is less than 2. Not less than or equal to, just less than. All the answers that you want, or all the answers to solve this equation, or I'm sorry, all the answers to solve this inequality, they're all less than 2. The way we show that with interval notation is negative infinity up to 2. Do you see the parallels between interval notation and the graph? The graph shows the starting point and then you shade everything above. Here, the starting point is always to the left. We go from the left to the right, okay? We're starting at 2, you go up to infinity. We're starting at negative infinity, you go up to 2. When I put this equal to sign in, greater than or equal to, what changes with the graph is I do a solid circle. What changes with interval notation is instead of this parenthesis, I have bracket. Okay, now we always have a parenthesis, guys, whenever we talk about infinity, because you technically can't end. Infinity goes on and on forever, so we never put a bracket there. But this is greater than or equal to 2. Greater than or equal to. Or equal to 2. Okay, this was just greater than 2. This is greater than or equal to 2. And same here, less than or equal to 2. So I'm going to have a shaded in circle. Okay, and to show that with interval notation, we're still starting at negative infinity, but this time we're going up to 2 and we include 2. One of my students one time said that she remembers that the bracket is what you use when you're including the or equal to, because in a bracket, this looks like equals. I don't know if that helps. I thought that was kind of cute. I learn a lot from my students. They're so smart. Okay, this is x is between negative 2 and 2. Open circle at negative 2, open circle at 2, and it's everything in between. Okay? So in other words, another way to say this is x is greater than negative 2, and at the same time, x is less than positive 2. It's in between negative 2 and positive 2. Another way to say that, and this is the way we're going to be doing later, absolute value of x is less than 2. Okay, think about that. Absolute value of x is less than 2. Oh, I forgot to write this up here. What was it? Less than or equal to 2. Less than or equal to 2. This one is between negative 2 and 2. Not including them. Now here's this weird part. This is how we write that in interval notation. Doesn't that kind of look like the ordered pair, negative 2, 2? Well, sorry about that. It's one of those things that we have to look at context clues to know what this means. Okay, if you're solving an inequality and you're writing your answers in interval notation, then you should realize that when I say the answers are, I put this as my answer, I'm not talking about an ordered pair. We're not even dealing with x's and y's. Okay, we'll just have x is between -2 and 2. It's just like, how do I know what I mean when I say the word bear? Am I talking about a bear in the woods? Or am I talking about how much I can bear? Okay, you know what I mean? So it depends on the context. Same with math sometimes. All right, this next one is x is less than -2 or x is greater than 2. X is less than -2 or x is greater than 2. In this case, it's or because I can't be both at the same time. I can't be less than -2 and greater than 2. It has to be one or the other. Okay, so the way we show that, and that's absolute value of x is greater than 2. The way I show that, guys, is -infinity to -2 in union with 2 to infinity. There's a union sign in between. This means in union with. Join these, together. It's either or. Okay? Less than -2 or, well, it says it there, greater than 2. That's what this is talking about, okay? Let's go to the next one. I don't know if you noticed, it's the same as 2 above, except for the equal to sign. I'm between -2 and 2, but I'm including -2 and 2. So that, again, we use our bracket. That's -2 to 2. It's stuff that's bigger than or equal to -2 and at the same time less than or equal to 2. It has to satisfy both those at the same time. This one is the same as above, except again, it has the equal to sign. So I'm going to say -infinity to -2 bracket in union with bracket 2 to infinity. Okay, so I have everything bigger than 2, everything less than -2. Okay, and including those. Go away. Okay. I'm not writing the words so much. This is, I don't have room. This is everything between -2 and 2 and including -2 and 2. This is everything less than or equal to -2 or everything greater than or equal to +2. It kind of says it right here. All right. Here, sometimes you have one of them with an equal and one of them not with an equal. Okay, so this is between -2 and 2, but I'm including the -2, not including the 2. It's like I'd have a closed circle at -2, but an open circle at 2. Here, I'm less than -2, or I'm bigger than or equal to 2. So I'm less than -2 with an open circle, or I'm bigger than or equal to 2. These are called half open, half closed type things. Okay. Now in your book, guys, I just want you to realize sometimes they don't use the open circles and the closed circles anymore. They use what they use for interval notation. So you might see parenthesis, or you might see a bracket and shaded right on the number line. Instead of the closed circle, you might see a bracket in some of the answers or some of the examples in the book. I accept either when I ask for a graph. Okay, you might see a bracket, everything below, instead of a closed circle. Here you might see parenthesis. Okay, so just know that if you're looking at a graph and you see parentheses, that's the open circle. That's the college algebra answer to the open circle. The bracket is the college algebra answer to the closed circle. Okay? So we are going to be wanting all our answers in interval notation. No more this. No more, okay? No more inequality notation. Interval notation is what we want. All right, so when solving inequalities, guys, not a big deal. I know you've been doing this forever now. The same rules apply as when I'm solving an equation, except, I think you remember, when you divide or multiply both sides by a negative. Okay, when you divide or multiply both sides by a negative. If you multiply or divide both sides by a negative, what do you have to do? Yep, you have to flip the sign. Okay, so example for this one, not a problem. Same rules as an equation. I subtract 1. I get 2x is less than or equal to 5. I divide by 2. I get x is less than or equal to 5/2. Okay, to write that answer, I don't let it like that. I say negative infinity to 5/2 or 2.5, however you want to write it. X is less than or equal to 5/2 is written this way. This shows me all the answers. Negative infinity up to 2.5. Any of those numbers that I want to pick in this interval from negative infinity to 2.5 will solve this inequality. Now, unfortunately, this one, I'll start out the same. So far, so good. I'm allowed to subtract. I didn't change the sign. It's less than or equal to. This one was less than or equal to the whole time. As soon as I divide by a negative, I have to flip the inequality sign. Instead of less than or equal to, now it's greater than or equal to. 5 divided by negative 2 is negative 2.5. So my answer is negative 2.5 up to infinity. That's what x is greater than or equal to negative 2.5. That's how you write that in interval notation. Okay? So just be careful. And the same thing as if I would multiply both sides by a negative. I have to flip the inequality sign, multiplying or dividing by a negative, and we end up getting, we end up getting a negative number, the opposite number that's over here if I multiply or divide. So I have to flip the sign to compensate for that. Okay? So the other thing that you'll have are something called compound inequalities. In a compound inequality, I want to solve both these. And I'm using the word and. So I want all the answers that are true for both. So for this one, I'll multiply both sides by negative 2. Oh, as soon as I hear that, multiply by a negative, I know I have to flip the sign. Instead of less than, it's greater. I'll add 5 and divide by 2. X is greater than 1/2, and see what happens here. Multiply both sides by 3. 3 is fine. It's positive. I can keep my greater than sign as it is. Subtract 1. I get x is bigger than negative 1/2. So what numbers are bigger than 1/2 and at the same time bigger than negative 1/2? Bigger than 1/2 and bigger than negative 1/2. If I think of it on a number line, bigger than 1/2, or bigger than negative 1/2 is all these. Bigger than 1/2 is all these. Which did I shade twice? Because I want it to be both. Right? I want to make sure it satisfies both. It says and. So my final answer is just 1/2 to infinity. It's just x is greater than 1/2. If I'm bigger than 1/2, then I'm definitely bigger than negative 1/2 too, right? But if I pick something down here like 0, yeah, 0 is bigger than negative 1/2, but 0 is not bigger than 1/2. Okay, if you use the word and, I want numbers that satisfy both. Okay, in this case, both were greater, so you kind of had to look and see which ones satisfy both. All right, we'll do the absolute value inequalities then on the very next video. See you then.